of Neutron and the networking, and we will compare this with an external SDN solution, in this case, Contrail. So my name is Thore Bahr. I'm working as an enterprise architect for SUSE, part of the sales team. I have a quite long history with OpenStack, now over 7 years. And in all the projects which I did, I realized networking is the most important part, but also the most difficult part. So in case of you stand in a lot of troubles, it's always good to have an expert on your side. So I'm very happy that I have Navin here.
Thank you.
Unfortunately, my English is better than your German, so we decided to make this session in English. You hear I'm not so. I always tell my English is not the yellow of the egg, but it goes. So I hope we have a good conversation and networking together. And if there are any questions, we have a section after that. But please introduce yourself. I'm just talking about.
Thank you, Thor. If this was in German, it would be just 2 words, Contrail and OpenStack. So good it is in English. So my name is Navin. I have been working in networking industry for a long time. I worked for enterprise networking, then service provider networking. Then I went and did a lot of research in networking. And now I work with SUSE in networking department. And I integrate OpenStack Cloud and other products with advanced networking products like Contrail.
Okay, so let's start. Short, quick view on the agenda. So we will have a short overview about what's Neutron. Then we will focus more on the network features inside of OpenStack as a point of view of the user itself. So what can a user do with such kind of network? We will have a look on how this is done in Open vSwitch, so the built-in features, and then we will have a look on how it's done in Contrail. We will use a use case like a data center to compare both parts a little bit. We will have a short summary and hopefully some time for Q&A. So let's start. What's Neutron? So scientifically spoken, neutron and protons are the building blocks for an atomic nucleon. So together with some electron, it's the base of all matters. So you see, it's very important for us as an environment. And on the other side, nobody of us will have ever seen a neutron. So side note by this, the average lifetime of a free neutron is about 15 minutes. I have no idea if this has something to do with some magic network packet loss in Neutron, but overall it was the name for the network project inside of Neutron. They started with the name Quantum, but they changed it to Neutron. And so I guess you will all agree that the network overall is very important for a cloud. So having a cloud without a network, maybe you have less trouble, but on the other side, it's more or less useless. So it's your spline, it's the backbone of your cloud. And if you have not a really strong and reliable network, you will have problems overall. But on the other side, networking is not really new. We are doing networking for years. We have also some problems. So what's so special in this Neutron way? I see there are 2 main factors behind this. First of all, it is a user-focused service. So the user itself is able to create a network. He decides which subnet will be used. He can create routers. He can play around with load balancers, firewalls. So he manages his own network by its own. And this is really a fundamental shift between the task of a network admin, maybe in your traditional silo-based organization, to the hand of the user itself. So we don't need people like Navin anymore, who want to get rid of the network admins. Nobody. Good decision, because they built the foundation for this. So without a good packet transport layer, the user will never be able to have this user experience. Second part, and this is maybe mostly the reason why Neutron is so scary, it's based on real modular architecture. So you have a central Neutron server, which acts as the API. So this is the interface to the user and gets the request, please create a network. But overall, the Neutron server has no idea how to do this. So you need a plugin which is able to fulfill the request. And here you can change, you can select different types of plugins. We have monolithic ones, which are mostly used for the integration of external SDNs. And in the built-in feature, mostly we use this modular layer 2 network, ML2 plugin. And there you have a lot of agents you can select to create your networks. So you select which features are used for this layer 2 networking, layer 3 networks. These are the base for all your additional services like load balancer, IP management, DNS as a service, firewall as a service, and so on. You can extend it. And this makes it so powerful, so flexible. On the other hand, you have so many choices you have to choose. And there are a lot of options to make trouble and to have the wrong ones. So this is the idea about networking in Neutron. So let's start to have some basic features. So what can a user do? And this is mostly the one often you start when you create your OpenStack installation. So you have already an existing layer with some database servers, application server, whatever, and you extend this with a cloud. And now you create your next virtual machine in OpenStack, and the task is, okay, I have to connect this virtual machine with my existing network. OpenStack introduces for this is called provider network. The name already, maybe it's something which the administrator has to create. So he will use an existing VLAN, create a network inside of OpenStack. OpenStack will get a range of free IP addresses, which it can manage. And then I, as a user, create my virtual machine and just connect my virtual machine to the network. Quite similar to as it's used to do in a traditional virtual environment. So not really a new and freedom of how to create networks, because I'm more or less doing the same. But it's the easiest one to do. So it's just if you want a Linux bridge, which is connected on the KVM side, and just connect to a VLAN. So there is no really a great reason to have trouble at the end, but no freedom, no overlays. So if we want to have some more freedom, we want to create our own networks. OpenStack has these nice self-service networks. So this is a network which I can create as a user. I decide which subnet it will be. I can create a subnet as many times as I want. So it's on my task to manage this. I can create my virtual machines, decide which IP addresses are them. This network is completely isolated from the outside. Normally, it is isolated from the tenant. So only inside of my project, I'm able to use this network. I can share them if I want, but normally they are isolated. Nice, but they are so isolated that no traffic will go outside and no traffic go inside. So again, quite useless. So if we want to connect different networks together that are able to communicate, we need a router. So if we have the next feature, we can create and add a router to our network. There is one basic requirement. We have an external network, which we can use as a gateway. This external network, again, have to be created by a nice network admin or a cloud administrator. So it's more or less the same as a provider network, just with a special tag. It's external, so it can be used for connecting the services. In this way, your virtual machines have now a way to the external network. The external network itself doesn't know anything about your subnet. So this is working in the same way as at home your Fritzbox. So we have a NAT service, which will map all traffic from the install side to its own external IP address, and this way it's able to route outside. So great, we have a way out, now we need a way in. So how to expose a service which is running here, or a node, to the outside. And for this, we have this floating IP. floating IP is an IP address of an external service or external network, which is then mapped to your virtual machine. This mapping is done on the router itself. The virtual machine doesn't care about it. You don't have to change anything. It's just a destination node on the router, which will convert all requests to this floating IP to the internal one. This makes updates, upgrades quite easy. You can create a new virtual machine, test everything, is it working? And if you want to get it available, you can just remap your floating IP from the old one to the new one. No change in DNS, no IP change on the client side, it's just a switch. So very, very easy. And now we are able to create our own networks. We are able to create our own routers. We are accessible from the outside. We can access the external ones. So quite fine. And again, without requesting any help from the network admin. But be sure, keep them happy, because without them, no packet at the end will follow the way and you will have problems. Besides this, we have some additional features. So this is basic layer 2, layer 3 things which we are doing in networking. Besides this, we have some additional services. I guess the most used one is load balancing. So especially in the cloud environment, we are speaking about cloud native applications. So we want to do a scale out, and we have the challenge, how can we distribute all the requests from the external side to the outside, and we need a load balancer. And the nice thing, I, as a user, don't care about which technology is used. I just hit the Neutron API, say, please be so kind, create a load balancer for me. And so now we have this floating IP connected to the load balancer, and this will distribute all my requests to my virtual machines. So also a fancy feature. In the same way, we have a firewall as a service, which is in front of the router, and this will control all traffic which is going inside or outside of my networking. Security, also one of the funniest things which I still, after 7 years, see at customers. We install a new cloud. We are happy, instance is launching, starting, and we try to SSH to it. Okay, no connection. And you're digging in, okay, networking, still some problems. And what mostly is forgotten, that you have a port security in front of each virtual machine. So OpenStack will take care about the whole traffic which is going inside a virtual machine and outside. So it's not possible, if you have started up a virtual machine and Neutron has managed an IP address to you, that you say, okay, I don't like it, I will change it to a different virtual machine. This traffic will never leave this machine or will be rerouted because of port security. And this also means you have to open an allowed traffic for your virtual machine. This is called security groups, and this is mostly forgotten. So you start up and think something is wrong, and it's just your security group, so you have to open the SSH port. Okay. So these are the basic features which we see in OpenStack, and with the built-in features, this is done with an ML2 plugin. Let's see how this is created inside of OpenStack. You see here the architecture of an OpenStack installation. I have only mentioned the services which are related to Neutron. So we have a controller, cloud controller node, we have a network node, and we have a compute node. The cloud controller node is running all central services which are needed. So here we have the Neutron server itself. It is storing all the information which are needed in the central database. Authentication and authorization is done by Keystone, so we need them. And the communication between all other services like agents or plugins is done via the message queue. Then we have Nova, because Nova is responsible for launching instances. But after it's launched up, it has a virtual interface. And now the task is how connect this interface to my network. So it's asking Neutron to say, hey, here's new great virtual machine. I have a virtual interface. Please be so kind, connect it to the right network. So it's speaking here with the Neutron server. The Neutron server, again, he is quite stupid, has no idea how to do it. So it's asking these services which are running on the network node itself. Here we have at least a Neutron plugin. The plugin is responsible for connecting your physical network to your OpenStack networks. So we have a first connection. Then we have the central services like DHCP agent, metadata service, or this routing instance, which is doing all the magic. So we have a lot of plugin agents. Everything is connected to the Open vSwitch. The Open vSwitch itself is then plugged via the layer 2 or the Neutron plugin to your network interfaces, your data network, and the traffic goes to the compute node, for example. There you also have the Neutron plugin again. It's managing, controlling more or less the Open vSwitch. Don't believe it's only one vSwitch you have there. There are a lot of one. You have some details for this. And now the plugin will connect the Open vSwitch to your physical interface and also to your compute node. So a lot of stuff on this side. So beside the plugins and agents, we also have drivers which we select. In the ML2 plugin, we have two types of drivers. First of all, we have this type driver. The type driver selects which network technology, so the physical network technology is chosen. For me, it's more the way which encapsulation technology is used. So will I separate my networks via VLAN, via VXLAN, or GRE? So what technology is used for creating my overlay networks? Then we have the mechanism driver. This is which toolset is used inside of my Linux machine to create the networks. So will it be just a Linux bridge? Will it be an Open vSwitch or something else? So here I have a lot of possibilities. And I can also combine them. So I can say my provider network should use a VLAN, but my self-service network, my overlay network, should be used by an VXLAN or whatever. So again, a lot of options. And you see here on the right side, the ways how all these agents and plugins are working together. I just have a focus on the right side. So here you see the Open vSwitch agent, and we can follow a packet from the virtual machine to the interface of the compute node. So you see, you have the instance. The instance has a virtual interface, and this is connected to a firewall. The firewall in the default setup is created by a Linux bridge with IP tables rule set. Why is it an IP tables and a Linux bridge? Because IP tables cannot be connected to an Open vSwitch. So you have for each instance a single bridge with just two connections and a bunch of IP tables rules in front of. So this Linux bridge is connected to your integration bridge. This is an Open vSwitch bridge. The Open vSwitch bridge will collect all instances itself together and will use an internal VLAN to separate the network. So if I have two virtual machines with the same network connected, they will have the same local VLAN, and it's used there. So now we have a self-service network, so it will be an overlay. So our integration bridge will be connected to the tunnel bridge. The tunnel bridge is the endpoint for all your VXLAN tunnels. So this is a mesh between all the nodes which are tunneling then the self-service traffic through your physical network. And so it's going to the interface. All the controls here are created via OpenFlow rules. Normally, the agents are running on your network node, and they are running inside of special namespaces. Who of you have ever worked with namespaces in Linux for networking? Okay, a lot of you. Who like it? Okay. Sorry. it could be really hard, and you have to understand how to work this. So if debugging, you want to debug this, you need a lot of stuff here. Okay, I see I'm talking too much from the time. Okay, but you see, there is a lot of networking inside of OpenStack, and you can think of, okay, how can I get rid out of it? And for this, an external SDN solution could be a solution. And this was the task to say, okay, Navin, please help me.
Sure, I'm here. So I will talk about Contrail. Thanks, Thore. What is Contrail? Okay. Well, if you look at the product manual definition, Contrail is an open source software-defined networking solution that automates and orchestrates the creation of highly scalable virtual networks. Now, if you go and search for Contrail, and the first result, if you go to the first result, it will take you to the product page, Juniper product page, and you're going to see a lot of products there. There is Contrail Multi-Cloud, Contrail Edge Cloud, too many. You must have guessed it by now that I will speak about Contrail networking. Okay, so what is Contrail networking?
I take care about my network admin.
Thank you.
Some water.
Well, it's easy. OpenStack follows a principle which is called batteries included. Okay, what that means, like if you want to deploy OpenStack in your laptop or in production, you will get everything you need to deploy all the services that Thore just explained. Okay. So if Neutron ML2 and OVS, if that is the default battery, SDN battery of OpenStack, then Contrail is nothing but an external set of batteries that you can replace with ML2 and OVS. That is what Contrail is. So here I would like to explain you a little bit about what this battery is made up of, how it functions internally, but the most important thing is how it connects with OpenStack. Okay? Before I do that, let us look at the history of Contrail. So software-defined networking is nothing new. Okay? We have been doing something similar to SDN even before the term SDN was invented. There have been a lot of research happening in this paradigm, software-defined networking, but it all picked up around 2012 time period with big acquisitions. And in that year, Juniper Networks acquired a company called Contrail System. They had built this SDN solution called Contrail. Since then, Juniper has built a lot of products around Contrail. And Juniper decided to open source the code base of Contrail. It became a community project called Open Contrail. A lot of things changed since then. Now we have cloud world and container world, and Contrail can act as a networking engine for Kubernetes as well. Recently, Open Contrail became part of Linux Foundation project, and the name changed to TungstenFabric. Technically, they are both similar product. The code base is the same. TungstenFabric is the open source version, and Juniper Contrail is the commercial supported version of Contrail. Okay. Now, next I'd like to explain you how Contrail integrates with OpenStack. So if you remember the slide which Thore explained of Neutron, ML2, and OVS, this is exactly similar to that. I have just replaced ML2 and OVS with Contrail here. So the first thing you will notice is the data plane. Here, I do not have any OVS here. I have something called vRouter. Okay. This is the data plane component of Contrail. Now, data plane is a fast path. Its job, it has only one job, okay? To do a lookup and forward the packet. Do a lookup, forward the packet. An agent, you need an agent to go and configure the tables or information so that data plane can do the lookup. In case of OVS, you run Neutron ML2, Neutron OVS agent for ML2. In case of Contrail, we run a different agent, a vRouter agent. Okay? So that is the data plane. Now, Neutron is the SDN, as I said, default SDN of OpenStack. When you want, with Contrail, you basically remove that control plane out of your OpenStack and run it separately outside. So if you see here, I don't have any network node now. all I have is Contrail controller node. Okay. How does OpenStack then communicate with this external controller? Well, for that you need Neutron plugin, okay? A Contrail Neutron plugin. Anytime you run a Neutron commands or you call in an API, that request is forwarded to an external controller. The external controller decides what to do and then configures the data plane component on each compute node. And that is how Contrail works compared to Neutron and ML2. Okay. Now, let's go a little bit more about the architecture of Contrail. So as I said, every SDN has two components, control plane and data plane. In case of Contrail, control plane is logically centralized but physically distributed control plane. What this means, there are different components of control plane. You can run them on multiple servers. Together, they act as a logically centralized entity. There are three types of node: config node, control node, analytics node. The name tells you what these nodes do. Okay? Config node keeps the current state of the network. What are the configuration? In case of virtual network, Neutron, you have subnet, ports, groups, security groups. All that information is stored in config node. The control node talks to different elements inside the network. vRouter, your external gateway, top of the rack switch, and it manages them using something called southbound protocol. Along with that, you also get another module, which is called analytics. This collects statistics, logs that can help you debug any issue that you may face with network. So that is a control plane. On the data plane side, you just have a forwarding engine, which is a kernel module, vRouter, and an agent that basically creates an information base for the forwarding engine to use. Okay. Now, the plugin that we have for Contrail is a very simple plugin. It's just a proxy. As I said, any request that comes to Neutron is sent directly to the controller. This plugin has its own advantages and disadvantages. Okay? Because it's a monolithic plugin, what it means like, it has to provide all the APIs and commands. Okay? In the sense, the controller has to provide everything. And it can cause few challenges when we have to test all of this. Okay? Now, how exactly does it work? I'll try to explain that. So what happens when you have a physical networking infrastructure, we call it underlay. That physical network infrastructure underlay provides IP layer connectivity to different components of your virtual network. Okay? Your compute nodes, your bare metal service, switches, gateways, etc. With Contrail, you create a mesh of tunnels on top of this physical underlay. Okay? And this mesh of tunnels gives you the platform to create virtual networks. Okay? In case of OVS and ML2, you have something called flows. Okay? A packet is forwarded based on flows. In Contrail, it is something similar, but instead of having flows, you have a thing called forward information base, which is made up of the host IP, the host MAC address, and MPLS labels, VNA identifiers, a lot of information that helps vRouter decide how do I forward my packet. Okay. Contrail uses standard data center protocols, L3 VPN, EVPN, for control plane. If you want L2 solution, you can go with EVPN. If you want L3 overlay, you can go with L3 VPN. And data plane uses different encapsulation protocol, MPLS over UDP, MPLS over GRE, and VXLAN. Now, in summary, Contrail provides you a few building blocks using which you can provide any kind of services, advanced services, to your virtual networks. Those building blocks are multi-tenancy, because each vRouter can now handle multiple virtual networks that you have defined for your tenants. The second thing is it provides this gateway connectivity. It can carry the traffic from your virtual network and take it to the physical network and even out of your data center. And the most interesting third piece is service chaining. With service chaining, I can do traffic engineering. I can move traffic from one node to another node in the way that I want. Okay? Now, to integrate OpenStack with Contrail, it's a bit challenging because you have two complex systems, a lot of moving pieces, and you have to integrate them in such a way that together they provide a better and a faster network to you. Just going to cover a few of the pieces. The first one is the components. As you saw, there are a lot of different components here. When it comes to Contrail, there are basically 4 components. One is a controller, one is a Neutron plugin, vRouter agent, and the kernel module. Few of these components, a vendor, we have to build. Others you can get directly from Juniper or the open source version. Now, these two systems must talk to each other. So you have a lot of configuration that should go from OpenStack into Contrail, and the other way around, a lot of configuration information that should go from Contrail into OpenStack. Okay? So you need to check all the configuration parameters of different components and make sure you provide the information needed to OpenStack or to Contrail. Now, each of these systems, they have their own deployment model. And it's not just an integration of two systems, it's also the integration of two deployment models. So if you take an example of SUSE OpenStack, we have Bahr, and Contrail has Ansible. So you have to integrate these two products in such a way that the deployment phase becomes easier for a cloud operator and network operator. Okay? Finally, once it is deployed, you have, during operations, you have all the modules you have for OpenStack, like OpenStack commands, Horizon, and you again get other management interfaces like Contrail UI and Contrail APIs, using which you can program the network. And last, you have to test all of this. Okay? If I'm replacing a battery with something else, I have to make sure that my remote controller still functions exactly the same. So you have to test it. Where we have Tempest test cases, at the same time, you also have Contrail provided test cases. So with that, I would like to give it back to Thore.
Yep.
So
now we get some information about what's built in, what are the features, what are the function of a Contrail-based solution. Now try to put this together. So let's start up discussing how we can create a data center with an OpenStack-based cloud. And so we can show up a little bit more our role. So me as a cloud engineer, you as a network engineer. And when I come to a customer, normally I see the first request, okay, we create our own OpenStack. We see a request from our users. We want to have an automated system for CD, CI integrated in Tempest. So we want to have some software testing in this development stage. So we need a system which is able to run virtual machines automatically, do some tests, and remove everything. So we have this integration in compute. We will have our own networks. We will want our own storage part. And this is the basic idea behind OpenStack, right? So I create this. I will have just my OpenStack nodes, and I know that all these basic features can be provided by the built-in ML2 plugin. So I'm just using OVS ML2 and create my network. As these are quite stupid Linux servers, there is just the request to the network organization, please make sure I need an IP connectivity. So please provide me some VLANs, I need some subnets, and make sure that the traffic can work together. Navin, can you provide this to me?
Definitely. You asked, I can provide you an IP level connectivity for different nodes. On top of it, I can give you a pool of IP addresses that you can use to reach the outside world, floating IP address pool. That's all I can provide you for this setup.
I'm fully fine with it. But I see, to be honest, I don't know which application exactly my users will run. So I expect a little bit of trouble. If there is the network speed not there, latency, something like this. And you know, I'm a compute guy. Yeah, I'm happy that I have a storage guy there, and I know that there are all these ML2 stuff, bridges, namespaces, all this part. Can you help on debugging me? Because I see it's still 2 layers. I have the transport layer, which you provide, but I'm not really sure where to look first if I run into problem.
Well, it's hard for me to debug your network because you're running a virtualized network, and I have no control of that. All I can do is I can tell you, depending on your application, you can use other technologies available to you that can help you reduce the latency or improve the performance. Something like DPDK, SRIOV. I can provide you servers which have DPDK-supported NIC. But then you have to go and configure them and use them.
Okay, so we need a different solution for this.
Yes.
Okay. Again, if we are fine with everything what's in ML2, can you do more for me?
Not if with this setup. If you move to Contrail, then I can do a lot more.
Okay, please explain a little bit more what to do if we want to have Contrail here.
Well, if you want to use Contrail here, as I explained, the first thing you have to do is you have to take out the SDN brain from your OpenStack and move it outside the OpenStack.
Okay.
That is the control plane, the controller. Contrail controller. So as you see here, all I have done here is I have moved the network controller from OpenStack into a separate outside entity, Contrail controller nodes. At the same time, I replaced the data plane on your compute nodes with vRouter. Okay.
Who will take care about these servers?
As a network engineer, I take care of these servers.
That's a good idea.
Okay.
But I see now the network is complete on your side.
Yes.
So you can also provide something, the quality of service. You can do something helping me analytics, statistics.
Yes. Now your demands have increased. So yes, I can provide you additional services. The reason I can provide you all of these services is very simple. Now, I have a control plane, network control plane, completely outside of your OpenStack, and this control plane provides me all the benefits that I get from SDN.
Okay.
Those benefits are abstraction, intelligence, and programmability. Okay. If you need something like quality of service, any networking feature like quality of service must be provided end-to-end. Okay. If it's not end-to-end, your quality of service, then it doesn't do any good. When you are trying to configure quality of service inside your virtual network, I can make sure that the similar parameter, same quality of service, is also provided from the underlay network, so that it is an end-to-end solution. So I can take care of the quality of service for you.
This is great, but this means for me 2 things. First of all, we see here a more integration, so we should team. We should work together now, and not just this request and answer scenario what we have currently. And I guess we should put the networking also to our diagram. Who was in the BMW talk? I would say. So if I look at this networking diagram, please, Navin, explain a little bit more. What are you doing there?
Yeah, it's not that difficult. It's actually easy.
You say it's easy.
Yeah, I'll try to explain you. As I said before, the SDN provides the abstraction of the virtual network for you. Okay? The same SDN solution can provide me the manageability and abstraction for the entire network that I have in the underlay. That includes the switches I have and the routers that I have. So all I'm doing is I'm merging your virtual network into my underlay network, so that there is no difference in these 2 networks. And I can manage and control both my physical network and your virtual network.
Okay, but then we have really a big dependency. So you are coupling us tightly. So what's happened if I upgrade my OpenStack installation, or are you upgrading your fabric? I guess this is not so easy.
No, we cannot work. We have to collaborate with each other from day 2. Okay. Any change in physical underlay should not cause any disruption to cloud services. Okay. So upgrade, downgrade, anything, we have to collaborate and then decide together how do we do that.
Okay. So in the case where it is not possible to have this tight combination about compute power, networking guys, I guess it's hard to do this. For this, we have still the possibility to do ML2,
Yes.
but with some other disadvantages. Okay, we have now a basic physical network, which is included in our OpenStack, and which also focus on the whole infrastructure, not only of the cloud. What more can we do?
Well, you need more services from the physical underlay. SDN can provide you additional services, let's say BGP as a service, DNS as a service, or bare metal as a service.
Bare metal as a service. I just got a request from our SAP development. They want to have an application server which is correctly connected directly to the database server. So in the traditional way, with the built-in capabilities, I would ask for a VLAN. How would this work in Contrail part? Are you also using VLAN for it?
No, VLAN is old-fashioned. VLAN is limited. VLAN is static. Okay. If I use, first of all, VLAN will have a limited number of VLANs that you can use. And the problem is, I have to propagate that VLAN information to the rest of my underlay cloud.
Okay.
It's not automated. So we're not going to use VLAN. We'll use standard protocols, tunneling.
Okay.
Let me give you an example how it works. You have a compute node, and inside that compute node, you have a virtual machine. That virtual machine is connected to a vRouter.
Okay.
In the real world, I have something similar. I have a bare metal server, and that bare metal server is connected to a physical switch.
Yeah.
Okay. Now, from a controller, I can manage and orchestrate the whole network such a way that a user, a virtual machine, see no difference for bare metal server. I can create a tunnel port directly from a switch port and bring that bare metal server inside your virtual network.
Okay, so easily spoken, you make no difference between our provider network or a self-service network.
Yes, there's no difference between provider network or self-service network here. It's just a single network, an SDN network. Okay. And moreover, if you do that, if you bring in a bare metal server into your virtual network, all the policies and security groups that you had defined for your virtual network, similar security groups are applied for your bare metal server as well now.
Okay.
Moreover, you can also do service chaining and do any kind of traffic engineering you want between the servers and the virtual machines.
Okay, and there is no change for the user. So he will just ask Neutron to say, okay, I want to have this network connection, I want this router, this service.
No, there
shouldn't
be any,
change the batteries.
Yes, there shouldn't be any change to user experience. If you change a battery in a remote control, you expect the remote control to work exactly the same. Okay? So it's fair to expect, like when you replace Neutron ML2 OVS with Contrail, the services that you are used to provide function exactly the same. Behind the scene, how the services work may differ, but to the end user, the service experience remains the same.
Okay, another question. So I know from my experience how the floating IP, the routing is done on the network nodes. And you explained you have a Contrail control plane, but no central network nodes anymore. So how is floating IP working then? Can you explain this?
Okay, let's take one example of floating IP. Before you had floating IP assigned to your network node. The traffic, north-south traffic would go to the network node, and from the network node, it would reach the virtual machine. Now, I don't have any network node. What happens, because I can provide abstraction of the physical network and the virtual network, the gateway that I have in my infrastructure can create a tunnel directly with each vRouter on the compute node. Okay? So the traffic can go directly from gateway to the compute node, and there's no network node involved.
Okay, great. Because it's always one of the difficulties in ML2 plugin. I know that you have this DVR thing which moves this routing to the compute board, but this means you have a lot of routing instances inside of your cloud, and each router needs an external IP address and service IP. And I guess this is something we don't see with Contrail.
No, you don't need that, because with Contrail you have visibility of that floating IP address. With Contrail, I am aware of where that floating IP is used on which compute node. It is not like I just give you a pool of IP address and you manage it.
Okay.
Now, from the SDN controller, I can manage everything. And that is the reason I can forward the traffic from the gateway directly to the compute node and remove the need for DVR. DVR is by default there in Contrail.
Okay, so I see we have, again, a whole solution. We can provide all these services locally. And maybe we should do a short outlook to what could be in the future for my customer. So if I want to extend my local cloud to another local cloud or to a public cloud, with this ML2 plugin, I have only very limited features to connect services from the outside. So yeah, we can use and provide a network, but it's very ugly because it's a pure network. You have to think how to get this to your external network, or you have to use something like a VPN as a service, which is also a little bit ugly. So could a technology like Contrail helps me on this side?
Definitely. So I already have a physical infrastructure in place to provide L2 or L3 level connectivity in different physical location data center. Now, because Contrail can provide abstraction, all I have to do is provide you an L2 or L3 level of abstraction for your virtual network. Okay? And because Contrail uses standard L3 protocols, standard L3 VPN and eVPN protocols, it is easy for me to provide that level of abstraction to the virtual world. Okay? As a user of OpenStack, you should not see any difference about where the VM is located.
Okay.
It's completely abstracted from you.
Okay, I see. So thank you so far. I guess this would be just an overview. Okay, how would it work with the built-in capabilities? How would it be working with Contrail? I see there are a lot of advantages, but it's not all golden. So there are also a paar any disadvantages. So let's sum up a little bit. I guess we see Neutron offers a lot of flexibility. You can use the built-in features. Also, there are a lot of features inside. You can combine it with an external one. We see this shift in the responsibility. On the one side, the user gets much more features. On the other hand, the network and the compute, and yeah, a little bit forgotten in this talk, the storage guys are also very important. You have an end-to-end responsibility for the service. So you have to work together. And I guess this is the most important experience what I had in all my OpenStack parts. If you are not able to get all these three parties to one table and they speak together and they understand together, you have really a problem to get a successful OpenStack story to this. So, on the other hand, you have a lot of options. So look for your use case. What do you really need? Because at the end, look at the KISS. Keep it simple and stupid. So don't try to over-engineer your solution. Use what is needed where it makes sense. If you have this good relationship to the networking, they also want to integrate other stuff in the software-defined networking. Solutions like Contrail are a good idea. If you have silos or if you have, for example, outsourced your networking resources, it will be hard to build this relationship. On this side, maybe using ML2 would be the better solution, but make sure that you have the right experience of this network service inside of OpenStack in-house and make sure that you're able to troubleshoot it. So there is always, so I don't see this is the best solution. So for everyone should use Contrail. I'm still not believe this. There are still easy solutions with just Linux bridges and provider networks for small installation. You can start up with it. So decide on your own. Have experience at the table, and if you don't have your own experience, ask an expert. So try to find your Navin. So thank you for this so far. We would have some minutes still for Q&A, and we have a lot of chameleons which have to be shared, and I don't know that, or I don't believe that someone of us want to bring them to home. So, questions? Oh, this is a one-way network. Yeah, so
Yeah, this is.
Third-party switches are allowed.
Right. So the question is do you have a strict requirement that it has to be a Contrail switch or a Contrail gateway? That is the question. The answer is no. The reason is it uses standard protocols. Okay. So OVSDB is a way to talk to a OVS-based switch. If your top-of-the-rack switch is OVSDB, OpenFlow-based, Contrail controller can speak OVSDB there. Same thing goes for the gateway. It uses BGP. So any gateway that supports BGP, Contrail is able to talk to that gateway. Okay.
What happens if the state differs, so the state in the Open Contrail state database to the Neutron database? So is there a syncing mechanism or something like that, or?
So if you remember the picture, there is no database, Neutron database right now with Contrail, because the entire database, the state, is managed by the SDN controller. Neutron forwards the request to SDN controller, and SDN controller keeps state information. So there's no question of state mismatch.
So each stage goes directly to the Contrail service.
But if I get it right, the network administrator can change the state in some way, so hook up external network devices and such, perhaps some route or something like that, and the Neutron part doesn't get it. So if I'm hooking new routes in the Neutron part again, are there any crashes or something like that, or?
As it's the same database, so if you do a change from the Contrail side, it will be just visible on the Neutron side, because then the request will be done from Neutron to the Contrail database, and the whole routing flow is completely done by the vRouter. So Neutron is more or less just a translator between the Neutron API request to the Contrail API. So there is no state anymore in Neutron itself.
Thank you.
Okay, everybody wants to go home.
And wants one of those cute little geckos. And of course, thank you very much for your inspiring talk. And
Thank you.
hope to see you again.